Two magnitude 6 earthquakes hit the Greek island of Crete in the past week, and both of them came with a tsunami warning, and then there was no tsunami in either case. So why do we have these warnings, and how are they actually issued? Let's talk about it. First of all, this is a seismically active zone. Magnitude 5 and 6 earthquakes are going to occur. You have two tectonic plates colliding with each other at a subduction zone. That's the African plate and the European plate, which is also why you have volcanoes in the region, the most famous of them being Santorini. The most important thing to remember with these tsunami warnings is they are the possibility of a tsunami, not 100% certainty that a tsunami is coming. These things are rapid response and they are instant, and they have to be because tsunamis move very fast. So they have to get messaging out there very rapidly. The way they do this is when an earthquake occurs and it is detected almost instantaneously, this is run through a system. Is it potentially big enough to hit a threshold that it might create a tsunami? And so those are automated tsunami warnings based purely on the size of the earthquake the second it is detected. The thresholds and conditions can vary depending on different tsunami warning systems. In this case, in Greece, a magnitude 5.5 threshold roughly is what can trigger that automated tsunami response. So for this magnitude 5.9 about a week ago and the 6.1 just yesterday, these both automated a possible tsunami warning. Not necessarily that one is coming, but there are other factors that control whether a tsunami will actually occur. Now, the size of an earthquake is going to matter. A magnitude 6 versus a magnitude 9 are going to produce very different outcomes for the possibility of a tsunami and also the potential size of the tsunami. The key thing to remember is that a tsunami is caused by a displacement of water, the movement of two different bodies of water next to each other, and this is primarily caused by a change or movement in the seafloor. Earthquakes can move the ground in different ways. So they can move the ground side to side, they can move it up and down, or a combination of the two where it's at an oblique angle. It can thrust things either over each other or away from each other. So these are normal versus reverse faulting. And so that's a big control on the possibility of a tsunami. Generally, complete side-by-side plate motion won't cause a huge displacement. Generally, up and down motion is more likely to cause a greater displacement and change at the surface. So for that reason, how the Earth physically moves during an earthquake is a big control. The other big key control is also the depth of the earthquake. The deeper an earthquake is, the more volume and time that energy has to dissipate. A shallower earthquake is more likely to create a sudden rupture and surface expression than a much, much deeper earthquake. So in these cases in Greece, they were slightly deeper and they were on the smaller side. And their mechanisms, so how the Earth moved, was not as much up and down, it was more side to side. So generally these factors combined together meant that wasn't really a tsunami that occurred.